Hello everyone, today we will be learning about the magic milk experiment.
Hi, I'm Anvarshi Gunindran.
Hey, I'm Hemala Chandran.
Hi, I'm Anusri Saravanan.
Hi, I'm Nitya Subramaniam.
So what is magic milk? Magic milk is the swirls of colors in the milk as dish soap and food coloring are added. Dish soap, which makes molecules to run around because it tries to attach to the fat molecules in milk. Food coloring is added to make it easier for us to observe the movement of the molecules. Next is the hero of our experiment, milk. 87% of milk is water. It also contains vitamins, minerals, proteins and fats. The two main ingredients of milk are water and lactose. Finally, milk is a non-polar molecule that does not dissolve in water. Glucose and galactose are present in milk because they are the products when lactose is broken down into monosaccharides. The next material of our experiment is the dish soap. It is a salt of a fatty acid mainly used as a surfactant for washing. The chemical formula is as shown. Dish soap is completely soluble in water, has a hydrophobic chain and a hydrophilic tail. The nonpolar end dissolves in nonpolar fats and oils, while the polar end dissolves in water. As you can see, this is the structural formula of the dish soap. The sodium end is ionic and very soluble in water, but the long hydrocarbon end is not soluble in water. It does dissolve in nonpolar substances such as oil or grease.
So, what really occurs in magic milk? Non-polar portion of the micelles break up and collect the non-polar fat molecules. The soap connects to a polar water molecule with the fat held inside the soap micelle. Due to soap connection, non-polar fat is carried by the polar water, and as soap races to connect with fat molecule roll, bend and contort in all directions. This causes the food coloring molecules to be bumped and shoved everywhere. Soap becomes evenly mixed with milk and slowly stops.
The ingredients needed for this experiment are whole milk, shallow bowl, food coloring and cotton swabs. First, milk is poured into a plate until the bottom of the plate is covered. Food colorings are added on top of it. A cotton swab, which is dipped into a dish soap, is dipped in the center of the plate. The colors start swirling around. The steps were repeated with low-fat milk. The swirling of milk was slower and occurred for a shorter period of time. The steps were next repeated with water. There was a quick splash of water due to the surface tension of water. Why does a milk with low fat content react for a shorter period of time? This is because there's less fat present to combine with all the soap molecules. Why was there a quick spread of colors when the cotton swab was dipped in the water? It is because of the surface tension. Was there a chemical reaction? No, there wasn't.
What is surface tension? Surface tension is the molecules on the surface of the liquid beat together on a little dome because of their molecular bonds. When the dish soap is dipped over the surface tension is broken because the dish soap breaks those bonds. This causes the colored milk or water to spread out over the surface.
This experiment shows how the weak chemical bonds that hold the proteins in the milk are altered when the dish soap is added. The molecules of fat and proteins bend, roll, and twist in all directions, causing the food coloring to react and look like exploding firework. In our daily life, we are using magic milk experiments mechanism every day. The mechanism for using soap to remove the dirt from our clothes is similar to the mechanism of magic milk. Just replace the fat molecules with dirt and you can see that it's similar to how dirt is removed from our clothes. The soap added to dirty water lowers surface tension of water and are emulsified to form oily dirt. Due to opposite polarity, water alone cannot penetrate the oil. The hydrophobic part of the soap gets attached to the dirt, while the hydrophilic part remains in contact with the water molecules. The soap molecules form micelles and trap the dirt at the center. The micelles do not precipitate and maintain their identity. This forms a colloidal solution and the trapped dirt can be easily rinsed off.